everyone. Today we are going to talk about the interference for waves and also talk about the beats. So first, let's start with the superposition. So what is the superposition for waves? So we know sound is a kind of wave, and it has its own frequency, has its own period. So today, the superposition is about the relation between two waves or more waves. So when we have two or more waves, they meet at the same place and the same time, they will interfere with each other. So the combining result of those waves is called superposition. And today we are mainly focusing on two kinds of superposition. One is called the constructive interference, and the other is called the destructive interference. So what is the constructive interference? So first we need to know a concept called in-phase. What is in-phase? So when we have two waves and they have the same frequency and they meet at the same place with same amplitude. So these two waves, we are saying they are in-phase. And for the constructive interference is we have two in-phase waves, and these two waves, they meet at the same place with always this top meet with top and this bottom meet with bottom. So together these two waves will produce a new wave. This new wave has double amplitude for each of them, and with the same period as each of them. So this is called constructive interference. So the result of constructive interference is with two same waves, they meet at the same place, they will produce a wave with double amplitude. The next concept called the constructive interference. So before that, we need to know what is out phase. So out phase is when two waves they meet at the same place with the same amplitude, but they will cancel out with each other. The amplitude of these two will be cancelled out. So let's draw a figure of the destructive interference. So suppose we have one wave moving along this direction, and then we have a second wave which is also, let's suppose, is moving along the same direction. But what we have, the second wave, the amplitude, you see the top now is with the second wave is the bottom. So these two can always cancel out with each other. So the result of these two waves, when they meet with each other, will cancel out with each other. So if now we build a wave result from these two, we will just adopt a straight line. So in real life, this destructive interference we can also use. So for example, in the airport, you see some people when they work, they wear these big headphones. So the reason is because there are a lot of noise in the airport. So people wear these headphones. The headphone has a certain frequency which can cancel out with the noise from the airport. So it will not influence their hearing. So that is unused for the destructive interference. So today we are going to use those concepts based on our computer program to build two waves. So we first build they are constructive with each other, which you will hear the noise level become higher. And then you will build a destructive interference, which you will hear the noise is cancelled out, so we cannot hear the noise. So that is a destructive interference. And after this measurement, we are going to do another one. It's called beats. So what is beats? Beats is when we have two overlap waves, and they are just a slightly different frequency from each other. So in this case, these two waves will produce the beats, and the beats is equal the difference of these the frequency of these two waves. So for example, we call the wave 1 has a frequency it's F1, and wave 2 has frequency is f2. Then the difference of these two frequencies will give us the number of the waves. So for example, f1 minus f2. So whatever this result is the number of the bits we are going to get. So for example, in this graph, I draw a figure of two waves. You can see they are slightly different with each other. In this case, you will see the result will be the result of these two. And the shape of the result will be like an envelope. The shape of this bits will look like an envelope, and the number of envelope is depending on what is different of these two frequencies, and the number will be equal to the bits. So now let's try to look at the computer, and we will do the program together from the computer. This is a computer program for the superposition of sound waves. As usual, you can put your name and the dates when you do this measurement. And in the beginning, it will show you some information about what is superposition, what is in-phase, out-of-phase, what is constructive interference, and what is destructive interference. So today, our goal is to build two experiments. One is for constructive and one is for destructive interference. And so before you start, we need to answer those questions. So when they are in phase, two waves, they are in phase with same amplitude, same wavelength, meet at the same place, same time. So what will happen? And then the second question, when you have two waves, they are out of phase, and what will happen? So basically we have talked about this. So one is for constructive interference and the other is for destructive interference. And so this is another information about the background information for what is the condition for two waves, they overlap and how they can constructive and destructive interference. And so now this is the program we are going to use to do this measurement. So in this program, you can see this red and green button. So these two control two different waves. And so you can see these are three hands. So one is to control the amplitude, and one is to control the period of the wave, and the other one is to control the phase. So this, once you build up your measurement, you can click this speaker and it will build up the sound from your measurement. So this is the measurement we are going to do. So we can start with the constructive interference. So the goal is we build two waves, so both of them with the same frequency as 440. So right now you can see this is 440.1. So we need to reduce the 0.1. So which you can do is click this or this side of the button. So one side is to increase the frequency and the other side is to decrease the frequency. So now, for example, I want to do on the red one. So I click the red one and then I change this to 440 for the red one. And then now I work on the green one. So the green one is already at 440. So for this one is already in phase for the two waves. So if I want to make them look different, so I can adjust this. So you can adjust the period of this green one, or you can adjust the amplitude. The amplitude, we cannot change the amplitude for now, but as you remember, for the constructive interference, these two waves they meet exactly at the same place, and then the top to top, bottom to bottom. So these two waves will build constructive interference. So now let's try. So this one is now 440, so we need to change this value to 440. Alright, so this one is also at 440, and they are in phase. And now let's try what will happen. Why there is no sound? As you can hear, there is a loud sound from the speaker, so they are building a constructive interference right now. So you can see the amplitude is increased because they are constructive interference with each other. So now let's stop this speaker. Now the next measurement. So now you need to answer the question, what is the shape when the two sound waves, the two phase when they are in phase? So now let's try what will happen if they are out of phase. So for example, I still choose the red one exactly as this one. And now let's work on this green one. When they are out of phase, which means the top will meet a bottom of the other wave. So I will adjust the phase. So now they just exactly top to bottom, top to bottom. And now see what will happen from the speaker. They're supposed to cancel out with each other. That's why we can see that it's straight line. So this is the out of phase condition. See, the result is we get a straight line from the canceling of these two waves. And the other one is, let's look at back, put it this back. And now you see this green color is the double amplitude from these two phases. So this is the case when these two, they are constructive with each other. So now you can answer these two questions. What is the shape of the two waves when they are in phase? So you can say the amplitude is increased. And now what is the shape of the two waves when they are out of phase? As you can see, it's almost like they cancel out with each other and give us a straight line. And so now this is the next measurement. So what they ask us to do is they want us to build a measurement, observe what happened to the output sound as the phase of each wave is shifted relative to each other. So they want us to use this. Now we have 4 waves. And from these 4 waves, we want to build a destructive interference. So destructive interference means, so the total result of the amplitude of these two phases will equal to 0. So they will cancel out with each other. So how to build this? So what we can do is we can build, for example, these two are out of phase with each other, and then these two are out of phase with each other. So the total will be 0 because these two canceled out and these two canceled out. Or what you can do is you can build these two are in phase, and also these two are in phase. But the in phase result of these two will be just cancel out with the magnitude of the red and the green one. So what I want to do is I will build this and this are auto phase, and then this and this are auto phase. So the total result is E0. So with the same, we can still choose the frequency is 440. So let's click the right one. So it is the amplitude is 1 and the frequency is 440. And now let's choose the other one. So if I want to make this green one is auto phase with the red one, so I can adjust this phase. So you can see now this green one will be cancelled out with this red one with each other, right? And so now let's work on this blue one. The same frequency, and the amplitude is the same, and everything else is the same. And now let's work on this purple one. So purple one, I want it to be auto phase with the green, with the blue one. So I need to adjust this just to be auto phase with the blue one. So now you can see the result of this wave is almost like E0. So I can try it. So you can see it starting with almost E0. So now I build a destructive interference from these two waves. So now you can answer the question with 4 waves, what you must do to achieve destructive interference. So as you can see, I built each of the 2 are destructive interference. So the total is E0. So those are the results you need to answer on your own. And also, these are the 2 you can also answer on your own. We talk about this example, how the noise cancelling headphone works. And this is an additional question. Sorry. You can also answer. If you have like those questions, if you have a hard time to answer, you can always email us, and we will be able to answer you on time. Please feel free to ask the questions by email. So after we are done, so we can close this one. Here, this is the second measurement, is the interference in sound beats. So it's the same as the earlier one. You need to write down your name and then look at the introduction part. And so this measurement basically is ask us to figure out how to make your own measurement, and it will build a beat. So there are 2 questions. First, what will happen when 2 sound waves with slightly different frequency occurs at the same time? Basically, you will have beats. And how will the frequency of the overall interference between the 2 waves compare to the difference of their individual frequencies? So the beats will be smaller than any of those frequencies. This is a background. You can read on your own time. Also, this one is. So now we start the measurement. It's the same software. One is control the amplitude, one is control the period, and the other one is control the phase. The same as the earlier one, but this one is ask us to build 2 waves with slightly different frequency. So for example, I choose the red one as the frequency 440, but I choose the green one as 444, and let's see what will happen. So now I choose this one to be 444. Now let's start the speaker. You can see these 2 frequency waves, different frequency waves, they just slightly different from each other. And see, it will produce a wave shape is changing with time. And now let's look at the measurement, what they are asking us to do. So first, what is the shape of the output sound waves when the two waves has a slightly difference in frequency? So the shape of these sound waves will like envelope. So we don't exactly see it here, but in the next measurement we will see it more clearly. And then what do you hear when the two waves have a slightly different frequency? So now this one, it asks us for this part, use the frequency to set the frequency for the red one is 440 and for the green one is 444 Hertz. And then after you set the frequency, adjust the horizontal axis scale so it shows about 1 second of time. To do this, click a number on the horizontal axis and drag it to the left. So basically they ask us to see during 1 minute how many of this envelope you can see. So let's try this measurement. So it asks one is at 444, one is at 440. So in this case, we already built this. This is 440, and the green one is 444. And now, what it asks me to change this time to be just 1 second. So I can put my mouse here, you can see, and I adjust this value to be 1 second. See. Here is 1 second. Alright. And so now what we will see. You can see 1, 1, 2. You can see almost every time in between this box, there are 4 different of envelope in between. So that is the difference between these two, the frequency of these two waves. So those are the beats. So the number of the beats is equal to the frequency difference. So that's why we have 4 beats here. Okay. So now you can answer the question, what was the number of the beats in 1 second? So you can count is, so this one and this one, this is 1, this is a half of the earlier, and this is the other half of the end. So there are 4 of them in between. And then how does the beats compare to the difference in frequency between the two tones you use? They are the same. The difference and the beats, they are equal with each other. And so those are the answers you need to answer, and the questions you need to answer. And the same, if you have questions, please feel free to email us and we will be able to help you. And then the other question is, what is the relationship of the frequency of two sound waves and the type of interference they produce? And then the other 2 questions you also need to answer. So this is 2 programs for the interference in sound waves. So one is about superposition and the other one is about the beats.